Final question, question number 25. This is the hardest one on the test. There are f fractions, m divided by n, with the properties. M and n are positive integers with m strictly less than n. M over n is in lowest terms. N is not divisible by the square of any integer larger than 1. And finally, the shortest sequence of consecutive digits that repeats consecutively and indefinitely in the decimal equivalent of m over n has length 6. The hardest part about these questions is understanding in the first place what they're even asking you to do. As an example, they've given 0.12745 repeating, where 745, 745, 745 just repeats. The shortest sequence of consecutive digits here is 745. That has length 3. We're looking for fractions where the shortest sequence of consecutive digits that repeats has length 6. So for example, that's going to be a fraction like 0.123456, 12345 dot dot dot. That's actually equal to 123456 divided by 999,999. That simplifies to 41152 over 333333. But there's a problem because this number is divisible by 9. We don't want the denominator to be divisible by the square of any integer larger than 1. So this does not count as one of our m over n's. M over n is going to take the form c divided by 10 to the power of p times 999,999. You can try any fraction, type in a number, and then divide it by 999,999. You'll get a decimal number which has a string of 6 things that repeat over and over and over. We can break that down into prime factorization. 10 to the p is equal to 2 to the p times 5 to the p times 3 squared times 7 times 11 times 13 times 37. N cannot be divisible by any perfect squares besides 1. We can't have it be a multiple of 4 or 100 or 25 or 9. So n has to just be a divisor of 2 times 5 times 3 times 7 times 11 times 13 times 37, which looks like 1111110. For example, m over n could be equal to 4,070 divided by 1,111,110. That looks like 1 over 273, which is equal to 0.003663, 0.03663, 0.03663, which repeats forever. So this passes our test of one of these kinds of fractions that the question is looking for. Lots of them are going to simplify down to that, but in general, the denominator can't be any larger than this number here. So there's 1,111,109 possible fractions. However, you have to check for overlap for smaller repeating patterns. For instance, you could have the number 123, 123, 123, 123. This fraction is no bueno because the shortest sequence of repeating digits actually has length 3. We have to check for repeating strings of 3 digits, 2 digits, or 1 digit. Now, how many ways can we make a fraction that has a repeating sequence of 3 digits? 1,109 ways. 2 digits is 329 ways, and 1 digit, that's 29 ways. Now, why is that? The general way to make a fraction that has a repeating sequence of 3 digits, a, b, c, divided by 999. That takes the general form of, again, c divided by 10 to the p times 999. Taking the prime factorization, that's 2 times 5 times 3 times 37, which is 1,110. There are this many fractions you can do that with. So from our original number of possible fractions, we have to subtract 1,109, we have to subtract 329, but we're going to add back 29 because these are going to be double counted. That gives us 1,109,700, and that's going to be our f. This is the number of fractions that satisfy all those 4 properties. How many digits does it have? That's 7 digits, because we're looking for g is equal to f plus the number of digits in f. So that's 1,109,707. Finally, the question asks for the sum of squares of the digits of g. That ends up being 181. So the answer to the final question is E. Props to you if you can follow along or if you can do these questions. You don't have to get a perfect score on this test to have a good score. I think showing the initiative of taking an extracurricular math test in the first place is already a step in the right direction.